Okay, in our last part of this problem, we went through and found the partial fraction decomposition for each of the terms that was in our Laplace transform. The next thing we're going to do is now go through and take the inverse Laplace transform. And when we do that, we'll have little y of t is equal to negative 1/9 plus a 1/3 times t plus a 37/9 e to the negative 3t. And then for the next piece, keep in mind again, this is part of a heavy side, so therefore we have to make sure that we take all of our t's and we shift them by t minus 2. So when we first shift the negative 5/9 constant, it doesn't change because it's a constant, and shifting something that stays the same keeps it the same. But for the next term, instead of being negative 1/3 t, it's negative 1/3 t minus 2. And then for the third term, instead of being just e to the negative 3t, it's going to be 5/9 e to the negative 3 times t minus 2. And again, you'll notice that those all have a t minus 2 in place of the usual t. This is now multiplied by the heavy side at t minus 2. So that right there is the actual solution of our problem. But once again, we need to go in and express this as a piecewise function since the original problem was posed in that same way. So now we're going to go through and define this as piecewise. And it's got two pieces. The first piece is just our negative 1/9 plus 1/3 t plus 37/9 e to the negative 3t. And that's for t values between 0 and 2. For the second piece, however, it's going to still have that first piece because it's always part of the solution. And then for the second piece, our heavy side takes on a value of 1. So now we're going to have those terms as well. So we're going to have a negative 5/9. And then we're going to have a negative 1/3 times t. Then if we distribute the negative 1/3 times the negative 2, that's a plus 2/3. And then we're going to have plus our 5/9 e to the negative 3 times t minus 2. And that's for t values greater than or equal to 2. Now, if you look very closely, you will notice that that 1/3 t and that negative 1/3 t are going to cancel out. And so does negative 1/9 minus 5/9 plus 2/3. That's basically negative 2/3 plus positive 2/3. So those cancel out as well. And all you're left with in that second piece is an exponential sum. So our y of t is negative 1/9 plus 1/3 t plus 37/9 e to negative 3t on the interval from 0 to 2. And then it's the sum of exponentials, 37/9 e to negative 3t plus 5/9 e to the negative 3 times t minus 2. And again, that's on the interval from t greater than or equal to 2 to infinity. And this actually makes sense if you think about it because our forcing term, which was linear, shuts off at 2. And you'll notice that that forcing term is actually missing and absent from the second part of the solution. It's just the exponential part, which came from the original differential equation's left-hand side.